All right, here's our first video in section 4.4 where we're going to be adding and subtracting polynomials. So hopefully you practice section 4.3 on polynomials and combining like terms because we're going to be using that in this section. We're going to be taking multiple different polynomials and we're going to be adding them together or subtracting them from each other. And so what we're going to do is we're going to distribute. We're going to multiply through by the number in front of the parentheses to get rid of the parentheses. Then we'll have a whole bunch of different terms, and we want to combine those like terms by, remember, combining their coefficients. But they're only like terms, remember, if they have the same variable with the same exponent. So remember, anytime we add or subtract different terms, what do we do with their exponents? Well, remember, we do nothing. So they have to be exactly the same. They have to be like terms in order to be able to add or subtract those polynomials, those terms in each polynomial together. Let me show you some examples. In example number 1, we're asked to take this polynomial, negative 5x cubed plus 6x minus 1, and add it to this polynomial, this trinomial, 4x cubed plus 3x squared plus 2. What we want to do first is we want to distribute whatever number is in front of that parenthesis to get rid of the parentheses first before we combine our like terms. And so if you look really closely, it doesn't look like there's any number in front of this parenthesis, but there really is. It's just an invisible 1, right? And so what we're going to do is we're going to take this 1 and we're going to distribute it or multiply it through to each term. So what number is in front of that second set of parentheses? Oh yeah, doesn't it look like there's also a positive 1 in front of that set of parentheses that we're going to distribute? So that's what we're going to do first. We're going to take these 1s and we're going to distribute it or multiply it through. So what's 1 times negative 5? Well, you should just get negative 5x squared, right? And what's 1 times, sorry, I didn't mean to erase. What's 1 times 6? 6x. And 1 times negative 1 is negative 1. So there's my pink. And then I want to take and I want to distribute this positive 1 through to the second polynomial. So what is 1 times 4x cubed? Well, we just get a 4x cubed, a positive 4x cubed. What's a positive 1 times a positive 3x squared? Well, that's where I get a positive 3x squared. And a positive 1 times a positive 2 gives me a positive 2. So now I have a whole bunch of different terms. I have no more parentheses. And so now all I have to do is just combine my like terms. Remember, they have to be the same variable with the same exponent in order to be considered like terms. So I'm going to go in standard form and I'm going to look for my highest degree first, which is my x cubed. I have a negative 5x cubed, I have a 4x cubed, and I should be able to combine those by adding or subtracting my coefficients together, and I end up getting a negative 1x cubed. It looks like I only have 1x squared here, so the 3x squared doesn't have any like terms, so I'm going to take that positive 3x squared and just drop that down. It looks like I don't have any like terms for my 6x, so I'm also going to take that positive 6x and just drop it down. And then I have a negative 1 and a positive 2, so negative 1 plus 2 gives me a positive 1. My final answer with all my like terms combined would be a negative 1x cubed plus 3x squared plus 6x plus 1. I have no other like terms. I'm in standard form, and so that looks like it's my final answer. Let's do another one. In B, we have two different polynomials that we want to add together. So what we want to do first is we want to get rid of these parentheses by distributing the numbers in front. It looks like, again, there's an invisible 1. So what's 1 times 2/3? What's 1 times 3? What's 1 times negative 7? And what's 1 times 1/2? I ended up getting 2/3 x to the 4th plus 3x squared minus 7x plus 1/2. I'm going to do the same thing with the second set of parentheses. What number is in front of that second set of parentheses? Yeah, positive 1, right? So 1 times negative 1/3 x to the 4th, 1 times 5x cubed, 1 times negative 3x squared, and so on. I ended up getting a plus negative 1/3, or you could just say minus 1/3 x to the 4th. I have a positive 5x cubed. I have a negative 3x squared plus 3x plus a negative 1/2, or you could just say minus 1/2. Now I'm going to combine all my like terms. Since all my parentheses are gone and all I have now is a whole bunch of different terms, I can simplify this big old polynomial by just combining my like terms. So I notice here I have a 2/3 x to the 4th and a negative 1/3 x to the 4th. Those are like terms because they both have x to the 4th. Remember, when we add and subtract, we do nothing with the exponent, but we combine our coefficients. And now, this one's a little bit tricky because it has fractions. And if you remember from your other previous math classes, that when we add and subtract fractions, we need to make sure that we have a common denominator. Well, it's kind of nice here that we already have a common denominator. So if I have a 2/3 plus a -1/3, or 2/3 minus 1/3, you should end up just getting a 1/3 x to the 4th. I'm going to combine my x cubes. It looks like there's only one of them, this 5x cubed, so I'm just going to drop that down. I have a 3x squared and a -3x squared that they kind of zero each other out. I have a -7x and a +3x. That gives me a -4x. And then I have a 1/2 and a -1/2. They zero each other out, and so I don't write that at the back. So my final answer is 1/3 x to the 4th plus 5x cubed minus 4x. All right, let's look at example number 3. I don't know if you can hear my dog barking in the background, but ignore him. All right, looking at example number 3, it asks us to add 1, 2, 3 different polynomials together now. And I'm going to do this one a little bit differently than the last few examples. I'm going to do this one using what we call columns. I'm going to take all of my like terms and I'm going to put them in columns. And then I'm going to add all the columns together. So I'm going to take this first polynomial and I'm going to write it with like terms in each column. I'm going to write my 9x to the 5th first. Do you notice that there's no x to the 4th? So I'm going to leave a little spot there. Then I have a -2x cubed. I have a 6x squared. You notice that there's no x term, so I'm going to leave a little spot for that one as well. And then I have a +3. I'm going to write my next polynomial. I have a 5x to the 4th, so I'm going to put that in the x to the 4th column. Remember that there was no x to the 4th in the first polynomial, but there is one in this one. Then I have a -7x squared, that goes in that column, and then I have a +6. Do the same thing for the third polynomial. I have a 3x to the 6th, that goes in its column. I have a -5x to the 5th. I have a +1x squared, and then I have a +5. And now all we have to do is add all of our columns together. So everything in the x to the 6th column, everything in the x to the 5th column we're going to add, everything in the 4th, the 3rd, the squared column, and then we have just our constants. So if I have just a 3x to the 6th alone in its column, I'm just going to drop that down. In my x to the 5th column, I have 9x to the 5th plus a -5x to the 5th, which is really a 4x to the 5th. In my x to the 4th column, I just have a 5x to the 4th, so I'm going to drop that down. In my x to the 3rd column, I just have a -2x to the 3rd. In my x squared column, I have 6 plus a -7 plus a 1. Well, 6 minus 7, or plus a -7, is -1. -1 plus 1 is 0. So that column just kind of goes away, zeroes out. I don't have anything in the next column, and then I have 3 plus 6 plus 5. You should end up getting 14. So my final answer, with all my like terms combined, is a 3x to the 6th plus 4x to the 5th plus 5x to the 4th minus 2x cubed plus 14. All my like terms are combined. I'm in standard form. I don't know if you like that way better, but it's a way to kind of help you stay organized into different columns if you like it better. Either way would work as long as you're careful and you don't miss any kind of signs or anything. You can choose to do either technique.